Yes, Shakir.
Yes, sir.
Yeah, I would tell this to you previously that there is an internet connectivity issue over here. Okay, it is raining and the weather is
Right.
not good. So, in case I get disconnected from the meeting, okay, there is no need
Yes,
to
sir.
leave the meeting. You just wait. I'll join right away with my phone's network. Okay.
Yeah. Okay, sir.
Okay. Let's wait for a couple of minutes. Let's see who else can join. After then we'll start. Okay. Okay. I guess I'll start now. It's already past 5:05. Okay. So, Shakir, you're there, right?
Yes, sir.
Yeah. Okay. So, yes. Good evening. This is the seventh live discussion on Geotechnical Engineering 1, and today's topic is permeability and methods for its determination. So, like the previous days, there will be MCQ, MSQ, true false, and numericals. I will first dictate all the questions, you write down all the questions, and then I'll give you some time to solve all the questions, and then after that I'll be discussing the answers of all the questions. Okay. So I guess we can
Yes, sir.
start. The first question is seepage velocity is, and the options are rate of discharge per unit cross section area of soil, rate of discharge per unit cross section area of voids, discharge velocity under constant head, discharge velocity under variable head. I'll repeat the question. Seepage velocity is rate of discharge per unit cross section area of soil, rate of discharge per unit cross section area of voids, discharge velocity under constant head, and discharge velocity under variable head. Okay. Next question. Permeability varies approximately. The options are linearly with grain size, as square of the grain size, as cube of the grain size, or none of these. I repeat the question. Permeability varies approximately linearly with grain size, square of the grain size, as cube of the grain size, or none of these. Next question. Permeability is, the options are directly proportional to unit weight of water, inversely proportional to unit weight of water, dependent on both the unit weight of soil and water, none of these. I repeat the question. Permeability is directly proportional to unit weight of water, inversely proportional to unit weight of water, dependent on both the unit weight of soil and water, or none of these. Next question. This is a numerical. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is, I'll repeat once, the discharge velocity given over here is 6 into 10 to the power minus 7 meter per second, and the same soil has a void ratio of 0.5. Then what will be the seepage velocity in 10 to the power minus 7 meter per second? You have to just state the number which will come before 10 to the power minus 7. Okay, with two places of decimal. The options are 12.18, 18.18, 12.62, and 18.62. I'll repeat once. The soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is, the options are 12.18, 18.18, 12.62, and 18.62. Next question. Yes. In a Darcian flow, the flow velocity is actual velocity, discharge velocity, seepage velocity, or none of these. Do you know what is Darcian flow, Shakir?
Yes, sir.
Yes, the flow which follows Darcy's law, right?
Darcy.
Yes. So in that Darcian flow, the flow velocity, which velocity do we consider as the flow velocity? The options are actual velocity, discharge velocity, seepage velocity, or none of these. Okay. Next question. Flow between any two points in a soil depends on the difference between Flow between any 2 points in a soil depends on the difference between. The options are pressure head, velocity head, datum head, or total head. I'll repeat once. Flow between any 2 points in a soil depends on the difference between. The options are pressure head, velocity head, datum head, or total head. Next question. For stiff clays, the permeability is determined by. For stiff clays, the permeability is determined by. The options are constant head test, variable head test, capillary permeability test, or consolidation test. For stiff clays, the permeability is determined by constant head test, variable head test, capillary permeability test, or consolidation test. Next question. This is a multiple select question, MSQ. Laboratory methods for determination of coefficient of permeability include. Laboratory methods for determination of coefficient of permeability include. The options are constant head test, pumping in tests, variable head test, consolidation test. And repeat once. Laboratory methods for determination of coefficient of permeability include constant head test, pumping in tests, variable head test, consolidation test. Okay. Next question. True or false statement? At a given porosity, the permeability of coarse grained soils is inversely proportional to the specific surface. I'll repeat once. At a given porosity, the permeability of coarse grained soils is inversely proportional to the specific surface. State this statement as true or false. At a given porosity, the permeability of coarse grained soils is inversely proportional to the specific surface. True or false? Next question. Yes. Permeability is, the options are directly proportional to the viscosity of water, inversely proportional to the viscosity of water, independent of the viscosity of water, logarithmically proportional to the viscosity of water. I'll repeat once. Permeability is, you have to tell me the relationship with the viscosity of water. Here I'm using water, it can be any fluid which is passing through the soil. So the options are directly proportional to the viscosity of water, inversely proportional to the viscosity of water, independent of the viscosity of water, or logarithmically proportional to the viscosity of water. Okay. Next question. A soil is said to be impermeable when the coefficient of permeability is. A soil is said to be impermeable when the coefficient of permeability is. You have to tell me the minimum range. Okay, the sorry, not the minimum range, the maximum range. Okay, I believe it is -7. So no, I was right. The minimum value of permeability which we can accept to say that a soil is permeable. Okay, so the options are less than 10 to the power -7 centimeter per second, less than 10 to the power -9 centimeter per second, less than 10 to the power -11 centimeter per second, less than 10 to the power -14 centimeter per second. Is this question clear, Shakir?
Yes, sir.
Yeah. So the minimum value of permeability up till which I can say that the soil is permeable, and if it reduces further, then the soil will be called as impermeable. Okay, so soil is said to be impermeable when the coefficient of permeability is less than 10 to the power -7 centimeter per second, less than 10 to the power -9 centimeter per second, less than 10 to the power -11 centimeter per second, and less than 10 to the power -14 centimeter per second. Okay, next question. Another true false statement. In sands, Darcy's law is valid and flow will be laminar as long as Reynolds number is less than 2000. In sands, Darcy's law is valid and flow will be laminar as long as Reynolds number is less than 2000. True or false? Just a minute. I'll repeat once. In science, Darcy's law is valid and flow will be laminar as long as Reynolds number is less than 2000. Is this statement true or false? Next question. With a rise in temperature, the permeability increases or decreases or remains constant or none of the above. What will happen to permeability if there is a change in temperature? Specifically here is a rise in temperature. With a rise in temperature, the permeability increases or decreases or remains constant or none of these. Next question. Another numerical. In a falling head permeameter test on a silty clay sample, the following results were obtained. Sample length is 12 centimeter, diameter is 80 millimeter, initial head was 1200 millimeter, final head was 400 millimeter, time for fall in head was 6 minutes, and the standpipe diameter was 4 millimeter. Find the coefficient of permeability in centimeter per second. Shakir, are you there?
Yes, sir.
Yes. Tell me one thing. Yeah, is the number of numericals which you solve in this live sessions, is it adequate or do you need more number of numericals?
Sir, if it is more, then it's okay, sir.
If it is more, then it is good, right?
Yeah, yeah, sir.
Yeah, because I try to keep like 5 or 6 numericals max to max, because the explanation for the numericals it takes time, right? And you have to solve it,
Yeah, yeah,
and people join. Since you are the single person in the meeting today, I'm just asking you because today I think it will not take so much time. But the other days, the explanation for the numerical it takes time because some of you have some
yes, sir.
queries, others don't. So I believe I should, if I give more number of numericals other than the theoretical questions, will be okay, right?
Yes, sir. Yes, sir.
Okay, good. Okay. So the question was, in a falling head permeameter test on a silty clay sample, the following results were obtained. Sample length was 12 centimeter. Sample diameter is 80 millimeter. Initial head was 1200 millimeter. Final head is 400 millimeter. Time for fall in head is 6 minutes, and the standpipe diameter is 4 millimeter. You have learnt, right, the falling head test in
Yes,
theoretical?
sir.
Yes. Okay. So find the coefficient of permeability of the soil in centimeter per second. The options are 9.289 10 to the power minus 5, 9.181 10 to the power minus 5, or in centimeter per second. 9.859 10 to the power minus 5, and 9.478 10 to the power minus 5. I hope you have noted down the values of the parameters. Okay, next question. According to Darcy's law, for flow through porous media, the velocity is proportional to. According to Darcy's law, for flow through porous media, the velocity is proportional to. The options are effective stress, hydraulic gradient, cohesion, and stability number. I'll repeat. According to Darcy's law, for flow through porous media, the velocity is proportional to. The options are effective stress, hydraulic gradient, cohesion, and stability number. Next question. Permeability in stratified soil deposits show greater magnitude in direction parallel to the stratification, perpendicular to the stratification, inclined to the stratification, or none of these. Is this question clear, Shakir?
Yes, sir.
Yes. So in stratified soil deposits, where there are more than one kind of layer with uh, different thickness and different value of coefficient of permeability K, then in which direction will the permeability be greater in magnitude? Will be more. So the options are parallel to stratification, perpendicular to stratification, inclined to stratification, or none of these. Shakir, how many classes you have attended till now? This live session?
Sir, without first, sir, all.
Without first all means you have attended six, right? Including today.
Yes, sir. Yes,
Include
sir.
this is the sixth class. Okay, so
This is
any.
seventh, sir.
Yes, yes.
This is seventh one, sir.
This is seventh class, but for you it is sixth, right? Because you haven't
Yeah, for
attended
me
the
sixth,
yeah,
sir.
yeah, for you it is sixth class. So in the last five classes and in today's, okay, I'll just ask you at the end of the questions. I'll give the question because I need to know if there's any suggestion for improvement of the PPT and all. Okay, I'll just ask you later.
Yeah.
Okay, so permeability in stratified soil deposits show greater magnitude in direction parallel to the stratification, perpendicular to the stratification, inclined to stratification, or none of these. Sorry. Next question. Another numerical. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting three horizontal layers if the thickness and permeability of the second layer are twice of those of the first, and those of the third layer twice those of second. If this is not clear, you can tell me. I'll just repeat and just tell you. It's in a clear way. Is this clear? The question?
Yes, sir.
Yeah. So you have to find out the ratio of average permeability in the horizontal to the vertical direction where the soil has three horizontal layers. Okay. Now the second layer, in the second layer, the thickness and permeability is twice that of the those of the first layer. And in case of the third layer, the thickness and permeability is twice those of the second layer. So in this condition, what is the ratio of the average permeability in horizontal direction to that in the vertical direction? Your options are 21 by 7, 3 by 7, 18 by 7, and 9 by 7. I repeat once. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability of the second layer are twice of those of the first and those of the third layer twice those of second? The options are 21 by 7, 3 by 7, 18 by 7, 9 by 7. Next question. Another.
Sir, 1 minute, sir. Last minute.
Okay, wait. Yeah.
Yeah, continue, sir.
Yeah. Okay. Thanks. Okay. Another numerical. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross sectional area if a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. Write down the variables very carefully. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross sectional area if a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. The options are 1.53, 1.65, 1.86, 1.78. I'll repeat once. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height, 50 cm square in cross sectional area when a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. Yes. Length of the soil is 6 centimeter. Yes. Okay. The options are 1.53, 1.65, 1.86, 1.78. Clear?
Yes, sir.
Yeah. Next question. This is the last question. Draw this diagram and then write this question. Once you finish drawing, tell me. I'll dictate once. Okay. In this diagram, this 2 and 4 given over here, they're in meter, okay? Because the soil is 4 meter thick, it has been said. So the head difference between the two piezometers and the thickness is 4 meter and 2 meter, okay? 2 meter this is, and this is 4 meter, okay? I believe you have drawn the diagram.
Yes, sir. Completely.
Yes, a sandy stratum 4 meter thick and having a slope of 3 is to 1, that is 3 horizontal is to 1 vertical, lies between two clay strata. This is sand, the soil over here, and impervious is the clay strata, which are almost impermeable. Two piezometer tubes inserted at points A and B 21 meter apart as per the horizontal distance, and water head was noted as shown. This is the water heads, and the difference was 2 meter. If quantity of water per meter width of the sand stratum was observed to be 5 liter per hour, that means per meter width, you have to take the dimension along the screen as 1 meter. Okay, per meter width of the sand stratum was observed to be 5 liter per hour. The permeability of the sand strata in meter per second is, the permeability of the sand strata in meter per second is. Once you finish writing, you tell me, okay, Shakir?
Yes, sir.
Yeah. Have you finished, Shakir, the question writing?
Yes.
Okay. So this was the last question. I'll give you some time to solve right now. Uh, will be okay if we start at 6 o'clock. It will take 40
Yeah.
minutes time.
Yes, sir.
Okay. Okay. So you take your time, and meanwhile, I'll just stop presenting. Okay, over here because it is showing some mirror image and it's create problem. You have written down all the questions, right? There's no
Yes, sir.
issue. Okay, you solve it. At 6 o'clock, we'll start this session. Okay.
Yes, sir.
Okay. Hello.
Yes, sir.
Yes, have you completed?
That's it. Three, four questions are there.
Yes, yes.
There's still three, four questions are there.
Three, four questions are left. So you need more time.
Yes, sir. So you start discussing, sir. At that time, I will
No,
see
if
those
you
questions
need
also.
some time, I'm giving you 3 more minutes. I start at 6 or 6. Okay. It's
Okay,
okay. We
sir.
have time. You're the only student now. So if you need
Okay,
some
okay,
time,
sir.
you can solve it. 3 more minutes I'm giving you. At 6 or 6, I'll start discussing. Okay.
Okay, sir.
Yeah. Okay. Have you solved the remaining questions, Sir Shakir?
Yes, sir.
Acha, before starting, I just want to ask you, since you have been a regular attendant of this session, is there any scope of improvement, uh, like with respect to the PPT number of numericals you've already said? Is there any like things I can do to make the session more engaging?
No, sir. It's okay, sir.
Is okay.
Yeah.
So, what do you suggest? I'll give more numericals and less theoretical questions, right? It will be good for you. What? I'll
Yes, sir.
I'll keep the same just content and just add the number of numericals.
Yes, sir.
Which one is which one is better? I'll keep the thing same and just add some number of numericals, right?
Yeah, sir. If numericals are more. almost sir, 5 to 6 or it's okay.
Yeah.
If we'll talk about more than that, then
I'll try to then
we need more
incorporate.
time also, na?
Yes, on the next sessions, I'll see if I can try to incorporate. I have to be a bit fast then because I generally
Yes, sir,
wait
it's a bit
for the number
really.
of students who are joining late actually. But in
Yes,
that
sir.
case, if the number of numericals like increase from 6 to 8, 9, I believe that will be uh, better, right? Because if I give
At
10
six, if it
numericals,
is 6 to 7 also is okay.
6 to 7 also. Okay, okay, 6 to
Yeah,
7.
if it is 10, then we need more time, sir. But
Yes, if it is
only
10,
two
you will
hours
be
we
needing,
can't
yeah, you're
complete.
needing more time. But yeah, I can give you like among those 10 sums, there will be four certain sums which will be like just one or two steps, and other six sums you need some time, and I'll just reduce the number of theoretical question if I can. Okay, I'll see whatever. I'll just incorporate.
Yes,
I'll try to incorporate. Means along with this PPT, like there are how many sums over here? There's one sum, two, three, four,
five, sir.
five sums, right? Over
Question.
here you have
Yes,
five
sir.
sums. Yeah, last day I think you had six sums, isn't it?
Yes, sir. Last also.
Last day also you have six sums. So along with this template, if I add three more sums, it will be like better, right? If I add two, three more sums.
Yes, sir.
Yes. Okay. Okay, Shakir. I'll try to keep it in mind. Thank you for your suggestion and thank you for attending the class regularly. Okay. So we'll start. Okay, now discussion. Yes. The first question was seepage velocity is. Seepage velocity is what? What is the answer?
First one, sir. Rate of
First
discharge
one,
for a cross-sectional area.
cross sectional area of soil. Think and tell.
Oh, sorry, sir. CP velocity, sir. Second one. Per unit cross-sectional area of voids.
Yes,
First one is, sir, discharge velocity.
yes. Because when there is a soil sample like this, if this is the cross sectional area, okay, and the water is flowing across like perpendicular to the screen of my laptop, okay, so and this is the soil particle like this, okay. Now, when we are considering the discharge velocity, then what do we do? In the numericals, we take the entire cross-section area, right? If suppose this is
Yes,
a
sir.
square, this is 2 and 2. So we take the cross-sectional area in the Darcy's law as 4 centimeter square, and then we solve the problems. So that velocity is the discharge velocity. But in reality, water does not pass through the solid particles, right? They pass through the voids. So that velocity through the voids, this is called the seepage velocity. So yes,
CP
seepage
velocity.
velocity is actually the rate of discharge per unit cross section area of voids. Good. Area of voids. The first one is the discharge velocity, right?
Yes, sir.
Yes. And the option number 3 and 4, it is just baseless actually, under constant head, under variable head. Even then, discharge velocity and simple velocity will come into play, but the condition is different, whether soil or area of voids. Next question. Permeability varies approximately
Yeah, square of the grain size.
square of the grain size. Okay, I'll not tell you the exact equation. If you know the Poiseuille's law and
Yes,
the
sir. That
Darcy's.
Allen Hubbard is.
Okay, you wait. There are more questions. We'll be discussing that in the second question, I believe. There is another question. So here it is a square, right?
Yes,
Permeability
sir.
K will be varying as per the square of the grain size. ds is the
Grain
diameter,
size.
effective diameter. Then it will be the square. This is the function, right? Relationship.
Yes, sir.
Yes. Okay. Now the next question. Permeability is, what is the answer over here?
Is directly proportional to water.
Directly proportional to the unit weight of water. Directly proportional to the unit weight. Just a minute. Unit weight of water. Yes. And what is the equation based on the Poiseuille's law and Darcy's law with the diameter and the unit weight of water? Okay, let us leave it over here. There is another question at the last. I believe we have solved that also. In that
Yes, sir.
question, I will just tell you the equation. I believe you know the equation. Even then, I'll just write down the equation over there. Okay. So yes, permeability is, if you write K like this, K is directly proportional to the unit weight of water, gamma W. Okay. So among all the other things constant, it will vary as per directly proportional to the unit weight. Clear?
Yes, sir.
Okay. Next question. Yes, discharge velocity this, void ratio is this, seepage velocity in 10 to the power minus 7 meter per second. What is the
The
answer?
second one, sir. 18.18
Second
into
one,
10 4 minus 7.
18.18. Yes. What is the first step you want to do over here? The first step is you have to find out the porosity, isn't it?
Yes, sir.
Find out the porosity, that is equals to E
Point 0.5
divided by
E
1
divided by
plus
1 plus
E.
E.
Yes. So what is the answer of porosity? 0.33, right?
0.33. Yes, sir.
0.33. Now the second step. What is the second step? Find out the
Discharge velocity is
seepage
seepage
velocity.
velocity is discharge velocity by porosity.
Yes. So if we write discharge velocity as V, then V divided by porosity will be the seepage velocity. So if we just keep 10 to the power minus 7 constant, we have to just, we will take 6 and divide 6 divided by
0.33.
0.33. That will give us 18.18 into 10 to the power minus 7 meter per second. So the
Minus
seepage velocity is 18.18 into 10 to the power minus 7, isn't it? Meter per second. Yes, any doubt? Hello? Any doubts, Shakir?
No,
Yes, Shakir, any doubt over here?
no, sir. No, sir.
Okay, okay. Next question. In a Darcian flow, the flow velocity is,
The discharge velocity.
yes, good, discharge velocity, because as I have mentioned,
Full cross sectional area is
yes,
considered.
as I mentioned in the first question, while we perform the numericals with respect to the Darcy's law, the area we take Q equals to KIA, that formula of that Darcy's law, Q equals to KIA, right? This is the formula of Darcy's law. So if this is the cross section of soil sample, is there anyone who messaged? Did you message or someone joined?
No, sir.
Okay, just a minute. Yeah. So this entire cross sectional area will be taken into consideration. Okay. And now the velocity. What is the velocity? Velocity is equals to Ki, right? V equals to Ki. So velocity
Yes, sir.
will be equal to Q by K, Q by A, isn't it?
Yes, sir.
Q by A. So here we are taking the entire thing, and so actual velocity, there is no such terminology as actual velocity. Discharge velocity is only the actual velocity because that we use while solving the Darcian flow problems. Okay, so the flow velocity in a Darcian flow is the discharge velocity. Good. I hope it's clear.
Yes, sir.
Yes. Next question. Flow between any two points in a soil depends on the difference between. What is the answer? Yes, Shakir.
Datum head.
Datum head. Think again. I have mentioned just a simple question. This is a basic thing. 2 points in a soil. The flow depends on.
Pressure head.
Think again. Because what you have said, I'll say both are applicable.
Total head.
You're guessing or what?
No, sir. You told us sir, both are means. Then
Yes, both are
datum head
applicable,
should be also
and
be considered.
yes, uh, generally velocity head, it is very what to say, the velocity of water in soil is very low. Okay, so generally we ignore, but still, if that negligible or minimum amount of velocity head we consider, then if there is a soil sample, the sum I have given you, there is a soil sample and there is a like flow in this direction, and we have installed piezometers like this, then this is the piezometer head or the pressure head, and if this is the datum, then this will be the datum head with respect to this z, and then velocity v square by 2g velocity head it will be. So entire thing, that is the summation of all these heads, okay, total head h t, if we say, will be the addition of, what is the pressure rate formula? Bernoulli's equation.
The
P by P by rho
rho
g.
phi P by rho g.
P, yes, P by rho g
V
plus
square by 2g
V square by 2g plus
plus
Z.
datum plus z.
Z. Yes. So this is the total head. So here pressure head will be having pressure head. This H P by rho g equals to this head difference. Okay, this is equals to H. Velocity head will be negligible, but still we'll be having any amount of velocity head, and datum head because height above the arbitrary datum we are considering. Now if there is any problem where it has been mentioned that the velocity head is the velocity is negligible, and the uh, datum head is constant, datum means the flow is taking place along the datum.
Generally.
Okay, then we can say the flow depends on the difference between pressure head only. Okay,
Yeah, I got
but
sir.
but since it is a very basic question, then I'll be applying the Bernoulli's equation, flow in pipes and all those things in fluid mechanics. That in if you apply the soil mechanics, then this is the answer, total head. Okay, is it
Yes,
clear? Yes. So total head, the velocity, the flow depends between, for flow between 2 points depends on the difference between the total head. Okay, in a soil. Next question. Yes. For stiff clays, the permeability is determined by. What is the answer?
the variable head test.
Variable head test. Variable head test is for stiff clays. It is for soil which might give low amount of permeability. That is for stiff.
Permeability.
Yes, yes.
The const we have two tests: constant head and falling head.
There are
Constant is
two tests.
for
What is this
where we
test?
get high permeability.
No, no, I
Okay.
understand, but there are more number of tests. These two are one type of test. There is another capillary test. This is also a kind of test. Do you know
Yeah, this is
about this
for
kind of test?
consolidation.
Yes,
Yes, sir.
consolidation test is performed where?
So for finding the time to consolidation of soils.
In that equation, in that consolidation equation, K equals to
The
K.
time factor.
Time factor is okay, but there is a relationship between uh, what is MV in that equation,
Sir?
MV and K. In one particular equation in the consolidation test, the permeability is there. Now, when we talk about consolidation, means removal of water from the soil
Yes, sir.
present in the voids. Okay, generally that kind of volume change with the what to say exclusion of water, okay, from the soil will occur in stiff clays. Stiff means it is now hardening, okay, and in case of clay the permeability is very less, almost proceeding towards impermeability. Okay,
Yes,
did you
sir.
get my point? The permeability in clay, especially stiff clays, is very less. I believe it is, yes, less than 10 to the power minus 6 K over here. In stiff clays, K is less than 10 to the power minus 6, and that too in centimeter per second. So in this kind of test, we cannot get any appreciable amount of water, or we cannot measure the appreciable amount of time change in constant head or variable head respectively. Because in constant head, all we need to do is measure the water, right? Which is, which get discharged, isn't it? In constant head test, Q.
Yes, sir.
Yes, and in variable head test, we need to find out the difference in head after a certain time t. Okay, but if k is so less, then that time will be approaching towards infinity, because the the difference will be coming at a very late time because k is so less. And if k is so less, then the discharge obtained in constant head test will be very small. So these two are ruled out. Capillary test is also ruled out because it has some specific conditions and not with respect to stiff clays. Only with respect to stiff clays, if we perform the consolidation test, when I talk about consolidation, when the live discussion will be on consolidation, then I'll definitely incorporate sums on this. But no, at this point, you can search any book. Okay, I'll just tell you. Shakir, are you there?
Yes, sir.
Yes. In case of consolidation, the particular equation which I am talking about is K by MV gamma W. Just a moment. Coefficient of volume change. Yes. Coefficient of
Okay, yeah.
volume change and coefficient of permeability. There is a relationship between them. Okay. Yes. Coefficient of consolidation CV equals to K by MV gamma W. Yes, this is the relation. K by MV gamma W. So using this relationship, using the consolidation test, if we know the coefficient of consolidation, if we know coefficient of volume change, I think yes, coefficient of volume change is MV and gamma W, then it will be easy for us to find out the coefficient of permeability of clays. Okay. Otherwise, using laboratory test, it will be difficult to find out. So consolidation test is an indirect test for only this kind of soil. Okay. So
Sir, if
this
it
is,
is only clay word,
yes, if it is only
yeah, the
clay
question
word,
was,
if it is only clay, then also you can go for consolidation test because clay has very less permeability. Clay is a kind of soil, okay. Clay is a kind of soil which has high porosity but very less permeability, okay.
okay,
But
sir.
question will not be there to confuse you, okay. If it is clay, then it will be removing the variable head and putting something else so that you can easily tick the consolidation test, because constant head test you cannot say for clay because it is only for coarse grained soil where we can get large volume of water in the discharge, okay. So
Sir,
your confusion, yeah,
as a clay,
yes, yes, Shakir.
sir, as a clay, will we consider this in a fine grained or granular material?
No, clay is obviously fine grained, but in this kind of question, I have mentioned over here stiff clays. So I'm telling consolidation test. If it was only clays, then you might have confusion whether you would go for variable head test or consolidation test, right? Because
Yes, sir.
variable head test is also performed for those kind of soils
Fine
where
grained
the
soil.
discharge is less, mainly silt
Very
and
low.
all.
Yeah.
Okay, but question will not be there to confuse you. I'm saying once again, if it is clay written only over here, then I think variable head test will not be there in the option, because variable head test is required. I believe it is required mainly, or it is feasible more for fine grained sand and silt. Okay, fine grained sand and
Yeah.
silt, variable head test will be more useful for constant head test, medium to coarse grained sand, and other kind of soils which are coarser than sand. And for clay, I believe consolidation is the main test that we can perform, because since, see, uh, in case of clay, the value of K is so less that it will not create any difference if we are not dealing with
Yes,
permeability
sir.
at all. Okay, so the only way, if we want to measure, we can measure is by using this indirect test. Clear?
Yes, sir. I got.
Yes. Okay. Next question. Yes, this is a very easy question. Laboratory methods.
The constant head and variable head test.
Yes, constant head and variable head or falling head test, because pumping in test is an in situ test. It is being performed
Yes,
in
sir.
the field. And I have mentioned the previous question, consolidation test is an indirect test. Okay, after consolidation process, we measure using the formulas and all for certain types of soils, especially stiff clays and stiff clays. Clear?
Yes, sir. I got.
Yes, constant head and variable head test. Good. Yes, the given porosity, the permeability of coarse grained soils is inversely proportional to the specific surface. True or false?
Sir, false.
Why?
Actually, it is inverse proportion to the square of the specific surface.
No. Specific surface, in the first question, in the previous question where I mentioned square, grain size means diameter. Okay, grain
Yes,
size
sir.
means diameter. But when I talk about specific surface, I'm not talking about the grain size. I am talking about the surface area per unit mass of of a certain mass of soil. Okay, surface area. If I take, suppose I take 4 gram of soil. Okay, then how much surface area I am getting for that 4 gram of soil? Surface area divided by 4 gram. Okay, and here I have mentioned coarse grained soil. So there was a hint in this question. Permeability, coarse grained soil, specific surface. For coarse grained soil, specific surface is low, isn't it?
Yes, sir.
Because if you take a certain amount of mass for fine grained and coarse grained, fine grained soil will be having more number of particles because they are fine grained. So it will have more specific surface. So, and coarse grained soil, they have more value of permeability, isn't it?
Yes, sir.
Sands and sand is more permeable, right? Than the, what to say, clay. Okay, so here inversely proportional means permeability will definitely increase with a decrease in specific surface. So if we say from clay to sand, there is a decrease in specific surface, right? Because fine grained to
Yes, sir.
coarse grained. So I'll say if it is fine grained, I'm going to towards coarse grained. Fine grained means clay. I'm going towards sand. So specific surface, what is happening? Specific surface, it is decreasing,
Degree.
right? Because clay is fine grained, it will have more number of particles. And simultaneously, what will happen? Clay to sand, the permeability, the permeability will be increasing, right? So you see, you can correlate this permeability with respect to the type of soil, with respect to Yes, with respect to whether it is fine grained or coarse grained soil, and finally you are correlating with respect to the specific gravity. So there was a hint in this question. You couldn't get it, but it is true. Okay, did you get it,
Yes, sir.
Shakir? So permeability is inversely proportional to the specific surface. And don't get confused with specific surface and grain size. Grain size means effective diameter D10. If nothing is
Yes, sir.
mentioned, the grain size is effective diameter D10. Okay, and it is specifically the diameter of the solid particles, so it is d square. If k is given, k is equals to cd square, where c is a constant. But over here I'm talking about specific surface. Yes, this is true. Next question. Permeability is, what is the answer?
Proportional to viscosity.
Yes, what proportional?
Inversely.
Yes, inversely proportional to the viscosity of water. Now I'll just write down the Poisson's law and Darcy's law combined equation. K equals to d square gamma w by viscosity eta into E cube divided by 1 plus E, and C. I believe C is a constant which depends on the. Just a minute. You know this equation, right?
Sir, no, different equation.
Different equation. What
Uh,
is the equation you know?
yeah, opposite है sir. K is equal to 1 by 1. There's K, but
Just
the
just a moment. Your voice is breaking. You just take it slow. K is equals to,
K is equal to 1 by KK. KK is constant into 1 by neta
yes, into 1 by specific surface,
into
like
n
that.
cube. Yeah, into n square constant. Actually, sir, we have two equation. In one equation, it is directly proportional to coefficient of viscosity, and in another equation, it's inversely proportional to. But I got
No,
confused in that
which
also.
equation you are talking about? But it is directly proportional to viscosity. It cannot be directly proportional to viscosity because permeability. Because when the water is more viscous, it is more thick. It will have difficulty in moving, right? Okay.
That Muscat Muscat equation. Kp is equal to
Muscat
K into the
equation.
neta by gamma.
Muscat
So actually,
equation.
this equation I learned in last semester, sir.
Okay. Kp for the physical permeability. Kp Darcy's coefficient of permeability as follows. Okay. Okay. Physical permeability. See, what was Kp? Kp equals to, tell
Coefficient
me,
of permeability, or we
K
can say
K into eta
Kp
by gamma W, right?
gamma W. Yes, sir.
Yes. Okay. Now understand this. This is the grain size. This is the void ratio E. C is a constant. Gamma W and eta in this equation. Okay. These are the only two. Mind it. These are the only two parameters which are concerning the properties of the permeant, that is the fluid, right?
Yes, sir.
So if you divide this equation by gamma w by eta, don't you get this equation? What is it doing? If we multiply k into eta gets cancelled, right? And if you divide k by gamma w gets cancelled, right?
Oh, okay, okay, sir. Sir, actually,
Okay.
I thought it is K is
No,
equal to
no, no.
Kp into neta by.
Kp is, if anywhere Kp is written like this, physical permeability according to Muscat, then it is the permeability which is depending only upon the properties of the medium, properties of the porous medium. Okay. Kp is physical permeability depending only upon the properties of the porous medium. Right?
Yeah, got it.
Yes. So don't get confused because eta over here is directly proportional to Kp. So you're getting confused, right?
Yes, sir.
Yes, but actually eta is getting getting cancelled over here. So there is no question of eta in this Kp equation. So Kp will be equal to what? Kp will be equal to d square e cube by 1 plus e into c, isn't it? Yes.
Yeah, sir.
Yes. So it is only dependent on the properties of the permeant. Very good question. Yes. So it is clear, right? This Muscat equation.
Yeah. Yes, sir. Yes.
Yes. Okay. Okay. Next question. This is inverse proportional viscosity water. Yes. Next question. A soil is said to be impermeable when the coefficient of permeability is very easy. What is the answer?
Actually, I don't know this, sir. I think it is
Yes, this
10 to the power
is
minus 9.
no 10 to the power minus 7. See, I have told
Actually,
in
I
the previous
don't.
question, right? 10 to the power minus 6 we take for the clays, stiff clays. 10 to the power minus 6 centimeter per second, right? We take for C6
Okay,
stiff
maximum value.
clays.
Then it will be minus.
Yes, so it will be 10 to the power minus 7 centimeter per second. Okay, next question, true false. This is also easy question. You know what is the
Sir,
answer?
false.
Yes. And what is the value of Reynolds number?
It should be equal or limiting value is 1, sir. Maximum
Yes.
or
So
less
Reynolds
than.
number will be less than equals to 1. What
1.
is the formula of Reynolds number?
So that
Rho
mu
V
d
E
by
divided by eta viscosity in CGS unit into G.
into
That will
G.
give us the dynamic viscosity mu if we take in fluid mechanics. Right. So rho v d by mu or rho v d by nu G. V is the velocity. Okay.
Yes, sir.
Yes. Next question. With the rise in temperature, the permeability, what happens?
That decreases.
Rise in temperature, permeability decreases. Okay. First, you tell me with a rise in temperature, what happens to the viscosity?
Mm,
If temperature rises, what happens to the viscosity? Because see, when we talk about rise in
the viscosity
temperature,
decreases.
viscosity decreases, right? When we talk about the
Yes,
rise
sir.
in temperature, this rise in temperature is going to affect the medium or the permeant. Permeant means the fluid which is like passing. If there is a medium like soil and the water is passing through the permeant, so rise in temperature is going to affect the medium or the permeant.
So medium, sir.
Medium in the soil. Will rise in temperature affect the soil particles? Change in the what to say? When we talk about fluid flow through soil, we are concerned about the packaging of the soil particles, right?
Yes, sir.
Yes. So any rise in temperature will it cause any significant? Will it cause any change in the packaging of the soil particles?
No, sir.
No. So rise in temperature will cause a change in what? The permeant, the fluid, right?
Yes, sir.
The fluid. This is the first thing. Now, how will the fluid change? Its viscosity will change. And so, if there is a
Yes,
rise in temperature, the viscosity will increase or decrease.
viscosity will
The thickness, the temperature is rising. The thickness, the viscosity, what will happen? It will decrease, right?
yes, sir.
It will decrease. And once the viscosity is decreasing, what will happen to K?
Okay. Yes, sir. Then it will increase.
It will increase, right? So temperature is rising, K or
Will
permeability
also
is
increase.
also rising. So it is temperature rises, K also rises. Okay, clear? Hello?
Yes, sir. Got it.
Yes, yes. Next question. Have you solved this question? What is the answer?
Sir, 1 minute, sir.
Okay.
Please get me. Please get me.
First, you have to find out the area of the sample, right?
Yes, sir.
Area equals to pi by 4 d square. What is the diameter of the sample? 80 mm. So if in
Mm.
centimeter it is 8
And 4
centimeter,
minus 3.
8 centimeter, right? 8 square. So what is the value of area? 50.265, right? Cm square. And then you will find out the area of the standpipe, cross sectional area, right? What is the cross sectional area? Zero point 0.4. I believe it is zero point 0.4 centimeter. Yes, zero point 0.4 is the value. 0.126. 0.126 centimeter square. Have you got these values for the area of the sample and the standpipe?
First in direct, then I change it.
Yes, what?
Actually, I wrote directly a small A, but in
Your voice is not clear. You go try to go slow. What have you done?
actually I wrote direct formula.
Yes, that formula you can write, but first we have to find out the area, right? Because K is, what is the formula of K? K is
Even
equals
I
to,
wrote, yeah, small a cross section area
what is the cross
into
sectional
length
area I've
divided by
taken?
area into t. Uh, 4 d square.
Yes, yes, okay, okay. You did it all at once. You're saying everything
Yeah,
at
yeah,
once
sir.
you did. What is the answer you have got?
But sir, I am getting different answers as compared to other four. Little bit, I think.
Which answer? What is the value you're getting?
I got 5 point something.
5 point something. No, no. See,
Yeah.
you calculate the area first. If you get this area, you put it, because L will be 12 centimeter. Time will be 360 seconds. Have you
Yes,
taken
sir. In
time?
terms of seconds.
360 seconds.
Yes, sir.
Yes, 360 seconds. And H1 is 120 centimeter, H2 is 40, I think, centimeter. Yes. Okay. You are saying, I'll just calculate it once again. Just a moment.
Mm, mm, mm,
0.126
mm, 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 mm. Yeah, sure. Mm, 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 mm.
I am getting an answer which is among
So
the.
1 minute, 1 minute, sir.
Yes, yes, yes. Take your time.
Mm, 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 Sir, 9.181.
9.181.
Yes, sir.
Yes. What have you done? What had you done wrongly earlier? Did you find it?
Yeah, sir. I wrote minutes per
You
minute.
wrote it in
Then I
minutes,
should,
6 minutes. You didn't take in second,
yeah,
right? 60
yeah.
into
Then
60.
I should convert minute in second. Then I,
Yes, 6
sir.
minutes, 6 into 60 seconds, 360 seconds. Clear? So these are
Yeah,
the
sir.
sum. This formula based. Okay. Next question. This is a very easy question. What is the answer? Velocity is proportional to,
Hydraulic gradient.
yes, hydraulic gradient. Other have no relationship with the velocity. What is stability number? Do you know stability number?
No, sir.
I don't think stability of slopes is there in the syllabus. If it's there, I'll be
That is the
saying
next.
next module. Okay, okay.
Yes, sir.
C by gamma HC. HC is the critical height of slope. Okay, but you don't need this right now, just for information sake. So yes, velocity proportional to hydraulic gradient. Okay. Next question. Permeability in stratified soil deposits show greater magnitude in direction. Which direction?
Stratifications.
Yes, which? What? Your voice got cut.
Sir, parallel. First one.
Parallel. Yes, parallel. Why parallel? Because in the formula, you know the formula, right?
Yes, sir.
Yes, the formula of K, when we are taking the certification flow parallel to it, it is,
K1 Z1.
yes,
Summation of K
it is
Z1 divided by
arithmetic
Z.
mean. Mind it, it is arithmetic mean of all the weighted
Yes, sir.
arithmetic mean. But when you're taking perpendicular, it is weighted geometric, weighted harmonic
Inverse
mean,
of.
weighted harmonic mean, isn't it?
Yes, sir.
You know harmonic mean, right?
Yeah, yeah, sir.
Yes. So in reality, arithmetic mean is always more than the harmonic mean. Hence, when we consider parallel, the the value of k will be more. Okay, because the formula for perpendicularity is what? K equals to z by z1 by k1 plus z2 by k2. Right? In that way, in that fashion, isn't it? Hello.
Yes, sir.
Yes. So that is the harmonic mean, and since we are talking about parallel to certification, it is the arithmetic mean, weighted arithmetic mean. It is more than harmonic mean, and hence it is greater. Clear?
Yes, sir.
It is not okay to know just it is greater. It is not why it is greater. You should know. Okay. Okay. Next
Yeah.
question. Same thing. I hope you have solved this question. What is the answer? This is the first layer, right? So it has
Yes, sir.
values k and z. K is the coefficient of permeability and z is the thickness. Second layer is twice of those of the first. Thickness and permeability both. So twice means it will be 2k and 2z, isn't it? And third layer twice of second. That is 4k and 4z. Clear? Now you put in the formula for k. If you say parallel, what is be the value? K1 Z1 plus K2 Z2 plus K3 Z3. So I'll take KZ plus 4KZ plus 16KZ. 16 plus 4 20 plus 1 21 KZ. 20 21 KZ divided by Z, that is divided by 7. 21 by 7 Z. Sorry, not Z, it will be K. 21 by 7 K. And K perpendicular. Are you solving it right now?
Yes, sir.
Okay. It will be Z, that is 7z divided by z by k plus z by k plus z by k. So 3z by k. So z it cancels 7 by 3. You have got this right. Have you got 21 by 7 in the first instance?
Nine, nine.
The answer is 9 by 7, but have you got like this, right?
Sir, I wrote this KH is K1Z1 plus twice K2Z2 plus K2 K3Z3. Then so it is first if we take K1Z1 as it is, then second time it is
Yes,
telling
yes, yes.
twice of K1Z1. Then third it will come.
Yes, K1 Z1
Uh,
or K whatever you take, you will get 21 by 7 in the first instance and 7 by 3 in the second instance, isn't it?
yes, sir.
Are you getting like this, right? Or you're just doing it all at once?
Yeah, yeah. No, I got, sir.
Yes, 21 by 7 into is divided by, so into what will be the value? 3 by 7. So 7 3 is a 21, it will be 9
9 by
by
7.
7. Yes, good. Okay, clear.
Yes,
Next
sir.
question. This is also a very easy question. I think by following Darcy's law, you can find out k, the value of k equals to, I think, q into L, q into L divided
Divided
by
by AHT.
a head difference to t. What is the value you are getting of k? In meter per day, mind it.
So actually, I got in meter per minute is 1.29. Then if we convert in days, it will come 1.8.
Convert it. 1.29 meter per minute. There is some
Yes, sir.
there is some exponent, right? See, I'm doing it. Okay. What is q is 430 ml means 430 cc.
Yes, sir. 10 to the power minus 3.
10 to the power minus 3.
Yeah, if we convert meters, sir.
Not meter. First do it in centimeter only. Everything is centimeter, okay? Now, area is how much? 50 cm square. Convert only once because conversion is tough. Into 50 into h. What is the head difference? 40, right?
40.
Then what is t? Time taken? 10 minutes, right? 10 into 60 seconds. That is 600. Now, this is in what? Centimeter per second? So, centimeter to meter. I have to divide by 100, right? And per second to per day. One day is 24 hours into number of seconds is 3600. Clear? This is
Yes,
in
sir.
centimeter per second and this is a conversion into meter per day. Now you do it and tell me. I think it will be 1.86 meter per day.
Yes, sir. Sir, but I did like this, but I'm not getting this answer.
You did in this way. Which way?
Sir, I
Just a
found
moment.
it in meter per minute.
Just a moment. Yes, meter per minute. What is your value in meter per minute? Tell me.
1.29.
1.29. No, it will not be in meter per minute because if it is in minute, just to convert it into day, you will be having to 24 into 60. 24 into 60. No, there is some difference in the decimals. I think you must check your sum. Don't see, the best thing is no need to convert anything to meter. Keep it in centimeter, do your numerical, and then you convert everything at once. So here, see, here it is 430 cc into L is 6 centimeter, 50 is centimeter square, 40 is in centimeter, 600 is in, okay, even if I do it in minutes, okay, 10 minutes I take over here, okay, I take 10 minutes over here, right?
Yes, sir.
So I'll be writing what, 60 over here, same thing, right? 600, 60 into 10, 60 into 60, so no difference.
Yes, sir.
So just check once, I believe there is some silly mistake might be there. Okay, it will be 1.86. Okay, if there is any change you can just tell me in the next class, I'll just
Yes,
correct it.
sir.
Okay, clear, Shakir?
Yes, sir.
Okay, last question. I'll just show you the result. This is the result. Have you found it like this? Could you do
Yes,
this
sir.
sum?
95 found it.
Could
First
you
I
do this
found
sum?
it by taking slope.
Yes, so have you taken
Yes.
the length as 22.13?
Yeah.
Because, yes, because the flow is taking place in this direction, to find out the length, and the head divided by the traverse will give you the value of hydraulic gradient I. Okay, so that will be, and here it is 3 horizontal to 1 vertical, so 21 over here, vertical is 7, so you can find out the length over here, 22.3 meter. This will be the length. Now Q is given in liter per hour. Okay, and the question
Okay.
demanded the answer in meter per second. So liter
Meter.
means 1000 liter equals to
10
1
to
meter
power
cube.
minus 3.
Yes, 10 to the power
Yes, sir.
minus 3, and here 60 into 60, that is hour to second.
Seconds.
You get this value of Q. Again, the same formula of the last sum, Q equals to KIA. KI means, what is the value of I? Head difference divided by the length of traverse, head difference 2 divided by this, to 22.13, okay, it is in meter, into area. Area is 4 into 1, taking unit length, means the unit length across the screen of this laptop or the screen of this PPT. So this is 4 and this is 1, taking 1 over here, this is the cross sectional area, and in this way you can find out the K will be, I think it will be equal to 3.82, something like that. Have you got the answer?
1 minute, sir. 8 minute.
Yeah, just calculate the answer. 3.82. Yes, 3.82.
So 3.817.
Yeah, 3.817 back to result is 3.82, right?
Yes, sir.
So I just cut it over here, just write 3.8. Okay,
Yes, sir.
okay. So all the questions are clear right now?
Yes, sir.
Yes, good. Okay, thank you for attending the class. I guess I'll see you next Saturday also, because you are a regular
Yes, sir.
attendant. Good. I'll just stop presenting. Okay, Shakir. Thank you. You can leave the meeting.
Yeah. Thank you, sir.